Okay, welcome to session 2 for lesson 4. As you'll notice, I've got a little different format for our slideshows, which makes our videos a little bit different, but I think this will work out a little bit better. Again, trying to find the best way to teach this math for everyone. So again, it's the developed portion of multiplying multi-digit numbers. Uh, what we've got here is a warm up for this lesson. This will also be very similar to your IXL homework at the very end. So, especially pay close attention to this part. So, the product, again, product is what the answer is for a multiplication problem. So, again, using the vocabulary a little bit more, getting used to that. These are problems that we can do in our head, and I'll show you the trick for that. When you see a problem that has even a single digit number or double digit number multiplied by a number with a zero in it, that's something that's going to work out to our advantage because let me show you this trick. You can multiply 3 times 2, which we know is 6, and then whatever zeros were in the problem or with the factors, we can use those over here. Just bring that 0, plop it in over there. Let's try this one. We've got 3 times 2, which is 6. You've got 1 0, 2 zeros, so we go 0 0. That's 600. Let's try it again with this one. 3 times 2 is 6. Simple enough. We've got 2 zeros here, 1 0 here, so let's do 1, 2, 3. That's 6,000. Pretty neat. Let's try it with this. 4 and 5. That's 20. We've got 1 0 here, so that gives us 200. You've got 6 and 7, which is 42. You've got a 0 here and a 0 here. Let's add those up over here. And we've got a 5 and a 2, which we know is 10. And let's do 1, 2, 3 zeros. 1, 2, 3. And we just did these really huge multi-digit problems, but if we know the tricks, we can do them in our heads and do them pretty quickly. So again, this will be your really helpful with today's IXL. All right. If you could open up to page 59 in your textbook, you're going to see a picture of some pens. And we're not going to solve this. We're just going to talk about what these what these word problems are asking for. Like, let's think about this logically. So there are 128 pens in a full box of pens. How many pens are in 35 full boxes? So let's look at these questions here in the bottom right. So what's the problem about? So um, it's about it's about finding the total number of pens if you have 35 full boxes. And that applies also to what are you trying to find out? So we want to know the total number of pens. And what information is important? Well, that's pretty simple. What's important is to know how many pens are in one box and then how many boxes you have. So when you have these word problems like this, it's really important to know what the heck they're asking for before you start doing the numbers. Just take a brief moment to take a step back and think about what should my final answer likely be? How's that going to help me out? So think of it that way. All right. So turn the page, and at the top of that page, you will see an area model. And what this is just showing you a way to find the answer. Again, area models and using the distributive property for math are simply ways of showing you where we get the standard algorithm or the traditional way of multiplying like you've been taught and that you're used to. So so this is breaking it down the problem of 128 times that 35. And you won't often have to do area models, but we'll come across them sometimes. So 128 breaks up into 100, the 20, and the 8. That 35 breaks up into the 30 and the 5. And if you notice, these problems. So this one right here is that 30 and that 100. This over here is also 30 times the 20. And this problem here is the 30 times the 8. And what you're doing is you're doing the area, which is length times width, or one side by another, to get these numbers. And down below, this is 5 times 100. This is 5 times 20 in this box, and this is 5 times 8. And all of these numbers, what you get inside here, like this is a partial product. So is this, 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 and this. And you add up your partial products to get your total product. So that is why we'd use the area model. You're already probably thinking it's so much faster to do it the standard way. Absolutely. But this is a way that you can break down the question visually. So this just gives you some theory. Down below on the same page, this uses the distributive property to find the partial products and add them. So this is another possible way to find the answer, but not the ideal way. But this is something we'll practice a little bit today in our notes. You can break this problem, 128 times 35, and take that 35 and break that into a 30 and a 5. And then that creates these two separate parts, 128 times 30 and 128 times 5. This one's right here, and this one's right over here. And in doing so, you can do 30 times 8, and then do 30 times 20, because technically this 2 is a 20, and then 30 times 100, because this 1 is not just a 1, it actually represents 100. And that gives us a partial product of that. Over here on this problem, we have 5 times 8, and then 5 times 20, because again, that 2 is actually a 20, and 5 times 100, because that 1 in 128 is actually 100, and gives us the second partial product. Okay, so that is using the distributive property. Next up. All right, let's talk about these questions. Let me erase this ink. There we go. Why is the area model divided into the 6 sections? So let's take a quick look at the area model again on the other page. Why do we have these 6 different sections? And 6. All right, we have those right there. Why? And that can be answered with, these are partial products. The measurement of that whole area is going to be our total product, but each one of those is a partial product, and there's 6 of them. So you could say there's 6 partial products. Number 2, how do the 3 partial products in each multiplication equation in the second modelet relate to the 3 sections in each row of the area model? Let me translate that sentence for you. What they want to know is, if you notice, the 30 times 8, 20, and 100, and the 5 times 8, 20, and 100, those 6 sentences, or those sentences right there, are the same as all of these. So if you notice, a distributive property is solved actually the same way as the area model way. It just kind of sets it up differently. So all 6 of those are represented in the distributive part too. Kind of interesting how that works. Will I expect you to solve your multiplication this way? No, but it's good to know. And okay. I'll use the partial products. Oh, so this is pretty easy. We have the partial products. What we have to do now is just add them up. Okay, so we got 0, we got 8. 8 plus 6 is 14, carry your 1. And 3 plus 1 is 4. So 4,480 pens. That's a lot of pens. but I'm sure they get lost over the course of school year, and that's actually probably as much as we need in one classroom. 4, with the product change in 30 times 5 on the left side of the area model where it changed to 20, 10, and 5. Let me show you what they're talking about. All right, so what they're talking about is if this was changed to 20 times 100 and 10 100, 10 times 100. Let's find out if this is going to make a difference. 20 times 100 is 2,000. 10 times 100 equals 1,000. We'll look at that. That's the same as 3,000, so it's not going to make a difference at all. As long as your numbers, as long as these numbers, the 20 and the 10, those factors equal this one, then you should be okay. You could split this up into 5, 6, 5, 5, 5, 5, 5, and 5, or 10, 10, and 10. You're still going to get the same. You're going to get the same amount in each box. So that's what they're meaning by that question. Moving on. Okay. 5 lists 2 different ways you could break up the factors, 239 and 64. To find the product, explain the 2 ways you would find the same product. Let's skip this question. So don't worry about that one. Say goodbye to number 5. Number 6, skip this one. Don't need it. Don't skip 7. It's actually a good one. All right. Pay close attention to this one. I'm going to show you a quick way to find this one. Somewhat quick. Find the product of 120 times 25 times 40. Does it matter what order you multiply the numbers? First of all, no. Adding and multiplication, the order never matters. But I'm going to show you a quick way to do this. I'm going to multiply 25 times 40. Now remember that warm-up we did at the very beginning? We're going to do this here. So just going to concentrate on these 2 numbers first. Let's do 4 times 25, which some of you know, 4 quarters, 25 cents, 25 cents, 25 cents. 25 cents is $1 or 100 cents. Plus this 0 gives us 1,000. And now we got to take care of this number. So let's do 120 times 1,000. And we can do 12 times 1. And then I've got 1 0. And then these 3 zeros. 1, 2, 3, 4. Look at that. I just did this all in my head. 120,000 is the answer for that one. So when you see zeros, rejoice, because that's going to make your multiplication easier. Next question, number 8. Find the volume of the rectangular prism. Well, what are we doing volume for? We already finished that. Well, we got to go back to it and remind ourselves. How's this problem similar to problem 7? Easy. Volume is length times width times height, which just so happens to use the same exact numbers as the problem above. And we can just glance up, and you know the volume's 120,000. Don't forget, it's cubic centimeters. How neat. Last part, number 8. Library bookshelf holds 156 books, and there's 15 bookshelves. Tell you what, you guys have worked hard enough. We're going to skip this problem and just have you move on to the other stuff. All right, so your homework is going to be IXL again. This time it's C3, multiplying numbers ending in zeros. I want you to get some practice on that. Plus, I found that doing that is just great warm-up and build some confidence with working with larger numbers. Remember, you only have to go to 70%. You can go to 80% or 100 if you want extra stuff for your Classcraft character. And let me know if you have any questions.